There's a result in geometry that tells us that if we have an angle inscribed in a circle, and here we see that angle right here, BAC, that angle will be half the central angle that subtends the same arc length. And here the arc you see is BC. So the result is that this angle, BDC, will be twice angle BAC. So how can we show that's true? Well, there are going to be three cases that we have to consider. The one case is where one side of the angle is the diameter of the circle and goes through the center point of the circle. A second case will be when the center point of the circle is interior to the inscribed angle, as shown here. And the third case will be when the center point of the circle is exterior to the inscribed angle, as shown here. So first, let me prove the result for the case 1, which is when the center point of the circle lies on the line AC. And here we mark the center point of the circle as the point D right here. Now, this is actually pretty straightforward to show. And in order to do that, let me call this angle right here, I'll call this angle D1. D1. And let me call this angle right here D2. D2. Now, we know that angle D1, this angle, plus this angle D2, the sum of D1 and D2 equals 180 degrees. Let me write that. D1 plus D2 equals 180 degrees. Now, we have triangle, this triangle ABD, that is an isosceles triangle because this side is equal to a radius of the circle, as is this side equal to a radius of the circle. So it means that this angle A and angle B are equal. And we also know that the sum of the three angles inside the circle are equal to 180 degrees. So we know that A plus B plus D1, which is that third angle, that also equals 180 degrees. Okay, now, so I have two equations here, two expressions, but in each case what we have on the left equals 180 degrees. So let me just simply subtract this expression right here on the top from this expression down here on the bottom. So if I do that, I get A plus B, if I subtract the top expression from the bottom expression, and A plus B, if you remember, is just equal to 2A. Remember, these are equal angles, so A plus B is 2A. 2A, subtract D1, D1's go, then I subtract this, so it's 2A minus D2 equal to 0. That's what I get when I subtract the top expression from the bottom expression. I have 2A minus D1 equals 0, but that is exactly the same thing as saying that 2A equals D2. Okay. So it's a pretty neat little result and a fairly straightforward way to show it. So I hope that little explanation was clear. If not, let me write this again. I'm saying I'm subtracting this expression from this expression. So let me write the bottom expression here. Okay, so I'm going to write the bottom expression is A plus B plus D1 equals 180. Or I'm going to just say it's 2A plus D1 equals 180. And the top expression says that D2 plus D1 D1 equals 180. And now let me subtract this equation from the top equation. Subtract 180 from 180 and I get 0. Subtract D1 from D1 and these two cancel out. So I have 2a and I subtract from that D1. So I have 2a minus, I'm sorry, minus D2, not D1. So I have 2a minus D2 equal to 180. So again, I get this result right in here, that 2a equals D2. And that's the result I was trying to show.